everybody. This is Indira, Assistant Professor of Institute of Aeronautical Engineering, Department of Mathematics. Today we are going to see how to find out the spectral matrix and modal matrix by bilinear transformations. So we are in problem solving of eigenvalues and eigenvectors of matrices. So the first one, before going to the process, let us recapitulate once again what is a modal matrix and what is a spectral matrix. Already in the last sessions we have done what is how to diagonalize the given matrix and what is a modal matrix and what is a spectral matrix. Okay, so modal matrix, the matrix P which is diagonalizable, the square matrix A is called modal matrix. The matrix P which diagonalizes the square matrix is called modal matrix. Suppose A is a matrix, then P is a modal matrix if P inverse AP is equal to the diagonal matrix. P inverse AP is equal to the diagonal matrix, and the resulting diagonal matrix is known as a spectral matrix. The resulting diagonal matrix is known as a spectral matrix. Now, let us go take one example. Determine the modal matrix P of the 3 into 3 matrices. The first row containing -2, 2, -3, second row 2, 1, -6, and third row -1, -2, 0. So verify that P inverse AP is a diagonal matrix. That means we need to get a spectral matrix by taking this. The procedure is that suppose A is a matrix. For the first step, we need to find out the eigenvalues. Next step, we need to find out the eigenvectors. In the third step of this diagonalization, that is the third step in the procedure of finding out the spectral matrix or modal matrix, we need to take the P value, which is nothing but the set of all eigenvectors that we have found it. Okay. Then find out the P inverse value, inverse of the matrix P inverse, and the fifth one, multiply P inverse with A into P, we'll get the diagonal matrix containing the eigenvalues lambda 1, lambda 2 and lambda 3 in the diagonal positions. And so here lambda 1, lambda 2, lambda 3 are the eigenvalues which I am referring. So this is a procedure which is lengthy procedure of finding out the spectral and modal matrices. So for this, the very first going to the first step, we need to find out the eigenvectors. So eigenvectors, how to find out the eigenvectors? It is given by determinant of A minus lambda is equal to 0. So lambda is nothing but the the eigenvalue that we need to find it out. So here we are going to get the linear equation as lambda minus 5 into lambda plus 3 whole square is equal to 0. Or lambda is equal to 5 minus 3 minus 3. Lambda is equal to 5 minus 3 minus 3. So now for these three values, we need to find out the eigenvectors. So if you find out the eigenvectors, then we can frame the matrix, modal matrix P, which is used to find convert the given matrix to the diagonal form. So lambda is equal to 5. The first case, lambda is equal to 5. So we have to substitute lambda is equal to 5 in A minus lambda I into x is equal to 0, where x is nothing but the set of x1, x2, x3, the three unknown values which we need to find it out, the column matrix. Right? Okay. So here wherever lambda is there, I've substituted 5. Okay. Actually, it is nothing but -2 minus lambda, 2 minus 3, 1 minus lambda, -6, -1 -2, and 0 minus lambda into the matrix X, the unknown matrix that we need to find it out, is equal to 0. So in this, we need to substitute the value of lambda is equal to, I have taken it as 5. So I got this matrix -7, 2 minus 3, 2 minus 4, 6, -1, -2, -5. So after solving, we will get the first eigenvector as 1, 2, minus 1. Similarly, the same procedure is followed to find out the eigenvalues for the next eigenvector, that is minus 3 and minus 3. So the two eigenvectors are given by 2, minus 1, 0, and x3 is given by 3, 0, 1. Now the next step of the procedure is to frame the modal matrix. Modal matrix is nothing but the set of the eigenvectors that you have got it. So P is equal to x1, x2, x3. So x1 is 1, 2, minus 1, and x2 is 2, minus 1, 0, and x3 is 3, 0, 1. So here we are going to get, first we need to find out the P inverse. So we should be sure that it is not a singular matrix. If it is a singular matrix, the inverse is not obtained. So a P inverse is not possible. So P should be a non-singular matrix. So for that I'll try to check the determinant of the matrix, and it came out to be minus 8. So which is not equal to 0. Therefore P is non-singular. P is non-singular. So if P is non-singular, you can find out the P inverse value. So how to find out the P inverse value? P inverse value is nothing but P inverse is equal to adjoint of P by determinant of P. Adjoint of P by determinant of P, and which is equal to minus 1 by 8, minus 1, minus 2, 3, minus 2, 4, 6, minus 1, minus 2, minus 5. Okay, so this is nothing but minus 1 by 8 into minus 1, minus 2, minus 3, minus 2, 4, 6, minus 1, minus 2, minus 5, and upon the product, and which is comes out to be 1 by 8, minus 5, minus 10, 15, 6, minus 12, minus 18, 3, 6, 15. So P inverse value is known. Now we have to post multiply P inverse with A into P, and we will be getting as minus 1 by 8, minus 40, 0, 0, 0, 24, 0, 0, 0, 24. And if you take or divide each term with 1 by 8, we are going to get as 5, 0, 0, 0, minus 3, 0, 0, 0, minus 3. Remember that 5, minus 3, minus 3 are the eigenvalues which we have got it. So the same values which we will get it in the diagonal form, and this is called as a spectral matrix. So diagonal. So this is how we can diagonalize the given matrix. And next, second example, we'll take the second example. Similarly, we here I have considered the 3 into 3 matrix. Remember that in the first step we need to find out the eigenvalues, next eigenvectors, next club all the eigenvectors to frame the modal matrix, next P inverse. Before finding out the P inverse, check whether P is singular or non-singular. If it is non-singular, then only you can proceed further, and P inverse is found out by using adjoint of A by adjoint of P by determinant of P. So lambda is equal to 1, 2, 3. So this is for these three values we need to find out the eigenvectors, and the eigenvectors that I have found out is are nothing but 1, minus 1, 0, minus 2, 1, 2, minus 1, minus 1, 1, 2. So this is called as a modal matrix, for which I have found out the P inverse. Just in the case of the first equation we have seen, same in the same model, I have found out the P inverse value, and P inverse is multiplied with A into P to get the diagonal form. After getting the diagonal form, the second one is nothing but the deduction. In the deduction, just we need to find out A to the power of 4, which is given by P into D to the power of 4 into P inverse. P into D to the power of 4 into P inverse. Already P is there, D is also there. So D to the power of 4 is nothing but 1 to the power of 4, 2 to the power of 4, and 3 to the power of 4. And which is nothing but after multiplying these three matrices, we are going to get it as minus 49, minus 50, minus 40, 65, 66, 40, 130, 130, and 130. So this is the A to the power of 4 that we have found by using the diagonal matrix, that is a spectral matrix. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.